In this video, we're going to explore base properties, an alternative consistency model used in distributed database systems. Base stands for basically available, soft state, and eventually consistent. We will look at each of these properties in detail to understand how they differ from the more traditional ACID properties. Let's compare base with ACID properties, which are commonly used in traditional databases. ACID stands for atomicity, consistency, isolation, and durability. Atomicity ensures that all operations within a transaction either complete successfully or none of them do. Consistency ensures that the database remains in a valid state before and after the transaction. Isolation ensures that concurrent transactions do not interfere with each other. Durability ensures that completed transactions persist even after system failures. ACID prioritizes consistency and reliability. Base, on the other hand, stands for basically available, soft state, and eventually consistent. Basically available means that the system guarantees availability. Soft state means that the system state may change over time. Eventually consistent means that the system will become consistent over time. Base prioritizes availability and performance, relaxing consistency requirements. Let's dive deeper into the first property of base. Basically available. Basically available means the system guarantees availability of the data. Every request receives a response, even if it's not the most recent data. The system continues to function even during partial failures. This approach prioritizes operational continuity over perfect consistency, allowing for graceful degradation rather than complete system failure. In essence, a system that is basically available always responds to requests, ensuring that the service remains accessible even when some parts of the system are experiencing issues. Now let's explore the second property, soft state. Soft state means that the state of the system may change over time, even without any input. Data can be temporarily inconsistent across different nodes in the system. The system doesn't enforce immediate consistency after write operations, allowing for asynchronous updates to propagate through the system. It accepts that state synchronization takes time in distributed systems. Therefore, during this period, different parts of the system might have slightly different versions of the data until all updates are fully propagated. Finally, let's understand eventually consistent. Eventually consistent means that the system will become consistent over time. Given enough time without any further updates, all replicas will converge to the same state. However, there are no guarantees about when this consistency will be achieved. This approach allows for higher throughput and availability during normal operation. It accepts temporary inconsistencies to improve the overall system performance. The system ensures that if you stop making updates to the data, at some point, all accesses to that data will return the latest updated value. Let's examine the ideal applications for base systems. These are perfect for social media feeds and timelines, content delivery networks, product catalogs and recommendations, analytics and metrics dashboards, notification systems, and caching layers. Now let's discuss when base is not suitable. It is not the right choice for financial transactions, healthcare record systems, inventory management, booking and reservation systems, critical infrastructure control, and any system that requires strong consistency. Here's an example of how base is used in NoSQL databases, specifically in Cassandra. This code demonstrates a write operation in Cassandra with eventual consistency. First, we create a Cassandra client, specifying the contact points and local data center. Then we define an insert query to add a user to the users table. Finally, we execute the query with a consistency level of quorum, meaning that a majority of the replicas must acknowledge the write for it to be considered successful. This ensures high availability, while still providing reasonable consistency guarantees. Let's summarize the key takeaways about base properties. First, basically available means the system guarantees availability even during partial failures, prioritizing operational continuity. Second, soft state means the system state may change over time without input, allowing for asynchronous updates. Third, eventually consistent means that given enough time, all replicas will converge to the same state without guarantees on timing. Base properties are fundamental to modern distributed systems that prioritize availability and partition tolerance over strict consistency. They enable scalable, resilient systems at the cost of relaxed consistency guarantees. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.